Welcome to the second episode of our drone technology series. Today we'll explore how GPS powers autonomous flight and the return to home feature. One of the most reliable features when operating, a drone is return to home or RTH. Holding a precise altitude while hovering or flying along a designated path at a constant speed also relies on satellite positioning systems. In this video, we'll break down the role of GPS in drones and what every operator needs to know before taking off. First, let's look at the relationship between drones and GPS and how position locking works. GPS, operated by the United States, is a satellite-based positioning system. A drone typically needs signals from at least 7 satellites to determine and hold its position. The more satellites acquired, the higher the accuracy. Receiving signals from 10 or more satellites ensures a stable flight. This satellite connection allows the drone to hover steadily, in place without drifting. It is also the core technology that enables the drone to return safely to its exact takeoff point if control signal is lost. Standard GPS accuracy ranges from 1 to 3 meters. However, high-precision RTK systems can reduce positioning errors down to a single centimeter. Second, let's discuss situations where GPS fails and how to handle them. Even advanced drones lose GPS signals in tunnels, between tall buildings, indoors, or in deep canyons. Solar storms or radio frequency interference can also affect signal stability. That's why checking the GPS status on your controller or app screen before takeoff is essential. For drones equipped with downward vision sensors, indoor hovering is possible even without GPS. However, keep in mind that emergency return to home will not function when GPS is unavailable. Third, here is how return to home actually works. When an RTH command is triggered, the drone follows a systematic procedure. Right after takeoff, it saves its satellite coordinates as the home point. If signal is lost or the pilot holds the RTH button, the drone climbs to a preset safe altitude and flies straight back to the home point using GPS. Once above the home point, it descends and lands automatically. There are key precautions here. Always wait until GPS lock is confirmed before taking off to ensure the home point is accurately saved. Set the RTH altitude higher than surrounding obstacles, typically 30 to 60 meters, to prevent collisions. Pilots can also override or cancel RTH manually at any time during the process. Fourth, let's clarify high-precision positioning systems. GPS, RTK, GLONASS, and Galileo. Standard GPS is built into most drones, offering accuracy within about 3 meters. RTK corrects errors in real time to achieve 1 to 2 centimeter accuracy, widely used in industrial and surveying drones. GLONASS, operated by Russia, serves as a supplemental satellite network, integrated into many advanced models. Galileo, developed by the European Union, is a highly accurate civilian satellite system supported by modern drones. Recent high-performance models such as the DJI Mini or Pro feature multi-band GNSS receivers that simultaneously connect to GPS, GLONASS, and Galileo for faster and more reliable satellite locks. Fifth, here are essential GPS rules every pilot must remember. First, always check GPS satellite reception status before takeoff. Next, verify that the return to home altitude matches your operating environment. Also, do not rush takeoff immediately. After powering on, wait for at least 10 satellites. Finally, in indoor or weak GPS areas, fly cautiously by relying on vision sensors and manual control. To wrap up, GPS is not just an extra feature, it is the core system, ensuring flight safety and operational reliability. Understanding how satellite positioning works is what keeps your drone from getting lost in the sky. In the next episode, we will cover internal flight sensors, the IMU, gyroscope, and accelerometer, and how they precisely stabilize the drone's attitude. If you found this video helpful, please like, subscribe, and turn on notifications. See you on the next flight. Thank you.